All right, boys and girls, this is Mr. Langley. Welcome to Potential and Kinetic Energy Notes. Potential and kinetic energy. This is something that you should have already learned about a couple of years ago, but we're going to have a quick review on this. Energy transformation review. Okay, so we already talked about this. What does the law of conservation of energy state? It says that energy can neither be created nor destroyed. It just transforms, which means it changes from one form to another. It's very, very, very much like the law of conservation of mass, which says that no new substance, no new matter can be made. It can only be changed. Energy cannot be created. It cannot be destroyed. It only transfers or changes through different forms. There are two main types of energy. Now, I know we've already talked about mechanical energy and radiant energy and sound energy and nuclear energy, electrical energy, but all of that can be put into two main categories. Potential energy, that is energy that is stored. It is energy that is waiting to be used. It is energy that is not being used right now. The other category is kinetic energy. That means energy that is in motion. Something is moving. So right here, very quickly, we see this girl who has pulled the bow back and she's just holding it. That is energy right there. You know there's energy in that string right there on the bow. It's just waiting to shoot that arrow, right? But it's not. It's still, that's potential energy. Kinetic energy is over here when the arrow is actually flying through the air. That's kinetic energy. Kinetic energy, energy in motion. This says energy of motion, okay? It's moving. Kinetic energy of an object depends on its mass and its speed. How much energy does something have? Well, that depends on how much mass it has. That means how heavy it is and how fast it's going, okay? Kinetic energy increases as mass increases or as speed increases. So real quickly, boys and girls, if there is a train going down the tracks, and that train, which weighs literally thousands and thousands and thousands of tons, that train is going down the tracks and it's going only 1 mile per hour. That is very slow. Most people walk at about 3 miles per hour. So you could be walking faster than that train is going. But if you get in front of that train that's going only 1 mile per hour, wow, it still has a lot of kinetic energy. Why? Because is it going fast? No, it's not going fast. But what does it have? It doesn't have speed. It does have mass, loads of mass. And so it still has a lot of kinetic energy. Not because it's going fast, but because it has so much mass, because it's so heavy. You're not going to be able to stop that train. It's only going 1 mile per hour, but you can't stop it. It's got way too much mass, which means it has way too much kinetic energy. Or let's take it the other way. What if we have a bullet? A bullet does not weigh very much at all. Bullets are very lightweight. They don't have very much mass to them. Well, then why is a bullet so deadly? Not because it's heavy. It's not heavy at all. It's got a lot of energy. It has a lot of kinetic energy because of its speed. It's going very fast, literally hundreds of miles per hour. Okay, there are some bullets that are going, close to 1,000 miles per hour. So that's where they have their energy, from their speed, not from their mass. What if you have something that has a lot of mass and a lot of speed? Well, that would be like the Apollo missions, the Apollo rockets or the Saturn V rocket, the Apollo missions that went to the moon. They had huge amount of mass. Those things weighed, oh boy, an incredible amount of mass, and they had an incredible amount of speed. As they were getting away from Earth's atmosphere, they were going over 17,000 miles per hour. 17,000 miles per hour. Some people thought that humans couldn't survive that kind of speed, that our bodies would fall apart going that fast. So a Saturn V rocket, the rocket that took men to the moon, that had an incredible amount of kinetic energy because it had speed and it had mass. Hey, look at that kinetic energy right up here in the top right corner. It's moving. If it's moving, that is kinetic energy. As an object goes down an incline, that means down a ramp, its speed increases, and so does its kinetic energy. When looking at a moving object, The lower it is to the ground, the more kinetic energy it has. So in other words, where does this thing swinging back and forth is a pendulum, okay? Where does this pendulum have the most energy? When it's up here at the top? Nope. When it's up here at the top, that's actually where it has the least amount of energy, kinetic energy. It's not moving as much up at the top there and top right there and right there. Okay, it's not moving as much once it gets to the top. It's actually slowing down so it can go back down the other way. Well, then where is it going the fastest? It's going the fastest right here at the bottom, right there at the bottom. And you know that. If you've ever stood in front of somebody who's swinging on a swing set, you don't stand right at the very bottom, because when they come down, that's where they're going the fastest. And if they hit you, you're going flying. If you're going to stand around somebody on a swing, where do you stand? Well, you stand way out here at the back. And maybe you've pushed your little brother or sister on the swing. You don't push them way down here where they're at the bottom. They're going to kick you in the face, and that's going to hurt. You stand behind them way back here at the back, because that's where they're going the slowest, and you push them. So kinetic energy, when it comes down, that's where it's going to have the most. When looking at a moving object, the lower it is to the ground, the more kinetic energy it has. Take a look right here at this skateboarder, right here on the ramp. This skateboarder does not have as much kinetic energy up here near the top. That's where they're actually going the slowest. Where do they have the most kinetic energy? Right down here in the bottom of this half pipe. This is called a half pipe. If you want to call it a curve, that's fine. Okay. So right here, right down there, that's where they're going the fastest. Where are they going the slowest? Right up here near the top over here, or right up near the top over here. Okay. Kinetic energy means they are moving. Where do they have the most motion? At the bottom of a ramp or at the bottom of a swing. Potential energy is the opposite. Potential energy is stored energy, energy of position. That means it's not moving at all, or it's moving very little. If something is 100% potential energy, that means it is not moving at all, not even a little bit. 100% potential energy means it's not moving at all. If you put your book on a tabletop, it has 100% potential energy because it's not moving. This type of energy has the ability to do work. That book could fall off of the table. If you pushed it over the edge, it would fall. Then it would have kinetic energy. It would be moving. That's also mechanical energy. The higher an object is, the more potential energy it contains. So if I put a book on my tabletop, then it has some potential energy. But if I take that book and I prop it up on, I open up the door and I prop it up on top of the door, that's even higher. It has even more potential energy. Now, neither one is moving, but if they did fall, which one is going to hurt your foot more? If a book drops off of a table, or if a book drops off of the top of a door? Or what if somebody puts the book on top of the roof, right over near the edge, and you're standing next to the roof of the school? It's even higher. If that falls off and lands on your foot, it's really going to hurt. So the higher up you put something, even though it's not moving, if it's just sitting still, the higher up it is, the farther it has to fall and the more potential energy it has, which means if it were to ever fall, it would have a lot more energy as it fell. Take a look at the skateboarder right here. At the top of the ramp, top of the half pipe right here, they have much more potential energy because they're going slower and not as much kinetic energy. Okay. Roller coaster. What is the relationship of the potential and kinetic energy as the roller coaster moves along the tracks? Well, if you are just sitting completely still right up here at the top, then you have 100% potential energy and 0% kinetic energy. As you go down the ramp, you start going faster, 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 which means you have less and less and less potential energy, and you're getting more and more and more kinetic energy. Kinetic means you're moving. So the faster you go, the more kinetic energy you have and the less potential energy you have. Where would you be going the fastest on this ramp? Right up here at the very top where you started? No, you know where you're going the fastest. You're going the fastest right here at the very bottom. That's where it's going to be 100% kinetic energy. You're moving as fast as you can. 0% potential energy. You are not sitting still even a little bit. You're going as fast as you can. As you go up the ramp, oh, you start to slow down, slow down, slow down. You're getting a lot more potential energy. Potential means you're slowing down, maybe even stopping. And then as you come back down, more kinetic energy. as you're coming down right in here. This is where you're going to be going the fastest, right in here. Then another time you go up, more potential energy, less kinetic energy. Then as you come down, more kinetic energy, less potential energy. All this means is the slower you are going, the more potential energy you have. The faster you are going, the more kinetic energy you have. Write that down somewhere. The faster you're going, the more kinetic energy you have, and the slower you are going, the more potential energy you have. If you are completely stopped, it is 100% potential energy. If you're going as fast as you can, it's 100% kinetic energy. Can it be 50-50? Sure. If you're only going half as fast as you know you could go, then you're 50-50. You're moving, that's kinetic energy, but you're not moving as fast as you could move, so you still have some potential energy in you. All right, so how does potential energy, that's PE, that is not PE like physical exercise, like going off to the gym. How does potential energy and kinetic energy, how do they change as the roller coaster moves along the track? I already said that. As you come down the track, you get more and more and more kinetic energy. In other words, you're moving faster, 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 and you have less and less and less potential energy. All right, I already talked about this. As you go up the ramp, you start to slow down, so you're getting more potential energy and less kinetic energy. And then as you come back down the ramp, you're losing potential energy and you're gaining kinetic energy. In other words, you're going faster. Anytime you're going faster, you're having more kinetic energy and less potential energy. Anytime you're slowing down, you're having more potential energy and less kinetic energy. But the kinetic energy and the potential energy, when you add it up together, it has to equal 100%. Okay, so guided practice. Use a picture to fill in the correct amount of potential energy and kinetic energy on your notes page. The notes page is in Canvas on one of the tabs in Canvas. If you have any questions about how to do this guided practice or how to fill in the notes, then please email your science teacher. Mr. Langley, I hope you learned something about kinetic energy and potential energy. The main thing you need to know is make sure that you know that kinetic energy means you're moving. Potential energy means you're not moving. At least you're not moving very much. If you have 100% kinetic energy, that means you are moving as fast as you can and you're not holding back any. You have zero potential energy. If you are sitting completely still, it's 100% potential energy and 0% kinetic energy. And if you're somewhere in between, it's 50% kinetic, 50% potential. That means you're moving, but you're just not moving as fast as you can. Please let your teacher know if you have any questions. Have a great day.